In lab number 10, we'll be implementing a key vault. Now, this key vault can be used to store three kinds of things: encryption keys, certificates, and secrets. Now, in lab 10, the key vault's key will be used to externalize the encryption of a SQL database. Now, generally, any sort of security mechanism that's available in Microsoft SQL Server is does not apply to the SQL DBA, the system administrator. So, in the event where we need to protect some data that should not be made accessible to the SQL DBA, our approach is to let the client. So here's a client program. We want the client program to have the rights to access a key vault. The key vault contains a key to decrypt data that's stored in the SQL database, while the SQL administrator, while the DBA, should not be allowed access to this key vault. Behind the scene, each column of the table will have a randomly generated symmetric operation key. The symmetric key is encrypted and stored in the data dictionary of the given database. In order to decrypt the symmetric key for that column and return the data to its original form, it is the application's responsibility to have access to the key vault, decrypt the symmetric key out of the data dictionary, and decrypt the actual content. As far as database is concerned, every column value would be nothing more than a series of binary data. Now, those bytes are typically not indexed or searchable in any way. There are two mechanisms of which we can encrypt the data: deterministic and non-deterministic. With a deterministic encryption, we can do equal queries because we can predict what the encrypted value is without using an additional salt randomized value. A randomized encryption, unfortunately, once you decide to use randomized encryption, is secure. It's more secure compared to deterministic, but at the same time, you will no longer be able to perform queries that has equality comparison. Now, for this lab, we're going to deploy the VM, get into it, and install SQL Studio and Visual Studio to protect data in the database and have an application using the ADO.NET driver to transparently to encrypt and decrypt the data as it go in and out of the database. So the purpose of this exercise is to secure data from the DBAs. All right, so here we are going to deploy an ARM template. All right, so I'm going to fast forward this. All right, now the deployment is on its way. We're going to put it on the back burner. We're going to create a key vault and ensure the asymmetric decryption key can be stored in that key vault, and also create a credential to use that key vault for decryption purpose. Now, key vault's job is to keep the key without ever revealing it. So with key vault, we define operations against the things we stored in it. Its job is never to reveal the key. All right, so let's go ahead and okay, let's make sure you're in the PowerShell. That's the bash. All right, so in the moment, once the key vault is created, we will receive the URL to the key vault. So in the meanwhile, I'll take a minute to go to the VM, install Visual Studio and SQL Development Studio. I'm going to fast forward this a little bit. All right, so you can see the HTTPS location. So all the artifacts that you put in the vault, for example, a key will be internet addressable. So all the operations are REST operations against those keys. Now, a program must be able to obtain an JWT for its identity, and the JWT must assert the claim that's defined in the access policy of the key vault. Okay, so now we are going to take a moment and go to the key vault and define the access policy. All right, so this is our key vault. But I need a notepad real quick. Oops, wrong guy. Forgot to write down the key vault URL. Kind of need it. Going to need it. All right, so this is our key vault URL. Now every key vault has only one access policy. So the general rule is make a key vault for one specific purpose. Do not create a key vault for a whole lot of different things. So in this case, we're going to do an always on encrypt against a SQL database. So make sure this key vault is dedicated just for that. All right, so here we can add an access policy. All right, so we're going to choose key, secret, and certificate management. Generally, we would separate the identity that manages the key vault away from the identity that make use of the key vault. So, for example, the C# program that we're going to build should be able to encrypt and decrypt, but it should not be able to recover, backup, restore, because we need clean separation of these responsibilities. But for this lab, we're going to select every single permission there is. All right. And we're going to grant permission to our own user account. So double check this is the account that you use to log in, as we will be using this as the principal to access the key vault. All right. So next, we're going to generate a key. All right. So that's a reference to the key. And this is going to add a software key. There we go. All right, so if you get this error, chances are you forget to click the save. Well, you didn't, I did. I always forget to click the save. So it's saying we don't see your name on this access policy. All right, so now hopefully that's taking care of that. All right, so now there it is. Now the key vault will remember every key that's ever generated. Okay. I think I copied the wrong command. That's the one I need to run again to generate the key. How did I mess this up? I should cut this from the video, but I will forget. Alright, so this is going to show us all the keys in the vault. All right. And you'll notice every key has a name. For example, this key is called My Lab Key. And as time goes on, you may have to rotate the key. Okay, the key vault will remember every key that's ever generated, unless you decide to purge it. So besides the key vault, we can also, besides keys, key vault can also store secret. So in this case, we're going to store this password string as a key vault secret. Unlike keys, secret is meant to be disclosed to authorized parties. So here we're going to create a secret called SQL password, and the secret will be available to people who have access, who are in the access policy to access this secret. All right, so there's that. Okay, so this is the object, okay, that represents the SQL secret, that is the SQL password. All right, so here we're going to do that IE enhanced security bit. And what we want is to download SQL Management Studio. Okay. All right, so it should be pretty self-explanatory. And then get Visual Studio where we add it. And then double-click install both tool into this lab virtual machine that we created through the template. All right, so I'm going to grab the Community Edition. All right, this will take a good 10 minutes to get the whole thing installed. Now with the Visual Studio, we need desktop and mobile. And select the .NET Desktop development. So we're going to be building some Windows forms. Now Visual Studio offers many different type of workload. So for this lab, we're going to install it with .NET Desktop development. All right, so while the installation is under progress, I'm going to minimize this. Now, next step, we are going to create an application principal. Now, this application principal will be the identity of the app that we're going to develop. Part of creating this identity, we need to obtain two pieces of information, which is the application ID followed by the application secret. Presenting these two pieces of info against the Azure AD token issuing point, we will be able to obtain a JWT, proving our identity. This identity will then be added to the access policy to use keys in the key vault we just created. So here we're going to go to app registration, and we're going to give the application we're about to build an identity. All right, so this will be the name of our app. We're not building a web app, so the redirect URI is inconsequential here. All right, so here there will be an application ID that uniquely identifies the application. So we gotta pull that into our notepad here. I'm gonna use it in a bit. It's a GUID. Now, besides application, now remember, human can provide username and password. Application cannot. So the way application can authenticate is via either knowing the secret or being able to present a certificate and the ownership of that certificate's private key prove its identity. So using either method, this is how our application can obtain the JWT representing itself. So this will be essentially just a password for the app. All right, So you get one chance to copy this to the clipboard. Now these are the two pieces of information that can authenticate an app to Azure AD. So next, we want to make sure this app is granted access to our Key Vault. So we're going to go back to the Key Vault policy like we did last time. So here's the Key Vault, and let's go to access policy. Okay, so it looks like we're actually going to do this via PowerShell. Fair enough. Fair enough. All right, so I'm going to copy this. And where's my QID? So this is my application ID. All right, so we set a variable, and let's get our Key Vault name. All right, so this next commandlet is going to allow our application to get wrap key, unwrap key, sign, verify, and list. So these are the operations our application will be allowed to do: wrap and unwrap key. All right. So typically we use wrap and unwrap keys to protect symmetric keys. All right, so that should do it. Do a quick refresh. All right, so you can see the SQL app now has the key permission, which just include wrap, unwrap. All right. So next we're going to create a SQL database, which we are going to encrypt. All right, database name is medical. And a SQL database requires a server to attach the database to, and it has to be globally unique. All right, and we are going to use our hard-coded names for this lab. All right. All right, so it looks like EastUS is not open for our Azure Pass subscription, so we're going to stick to EastUS 2. It's going to be a little bit of travel from our app to our database. All right, so I'm going to go ahead and create this database. All right, so deployment is underway. I'm going to fast forward this a bit. All right, so here I'm at the SQL database. In order for our VM to connect to the database, we need to allow public access, or allow access from the VM. So allow Azure services and resources. That should do it. Okay. Now, if you, yeah, there's that. So go ahead and save that. Now, I just want to quickly find out what is my IP that's assigned to this VM. We're installing Visual Studio and SQL Server Management Studio. So that is the IP address. And make sure that is added. All right. So this allows connection to that SQL Server database. All right. So now I'm going to fire up SQL Server Management Studio that we've just installed. All right. So while waiting for this install to finish, Now that your database is ready, please go to the database, show your database connection string. We will be using ado.net as our driver, so make sure that's recorded. Okay. Now, while at it, you gotta change the password to match what we configured, which is that guy right there. Okay, so make sure the connection string is available in your notepad. Alright, so here's a SQL Server Management Studio. We'll use this to connect to our Azure SQL database. Alright, so there are a few ways to connecting to the database engine. Windows authentication if this machine is joined to a Windows AD. SQL Server authentication is what we're going to use for this lab. Other choices, if you have set up Azure Active Directory admin and your machine is Azure AD joined, then you can do integrated sign-on. Okay. Otherwise, you can say, I want to connect to this SQL Server using my Azure account. Okay, and universal with MFA. Now you have to make sure your database is configured to accept Azure AD admins. That should be on the server settings. So go to Overview. Click on the server name. Okay, so you're going to have to set a Azure Active Directory admin before you can try to connect to the database using your Azure AD credential. Now we'll skip that in this lab. We have hard-coded SQL Server authentication. Now you can pull out the server name by your connection string. So that is our server. Login. And the password. All right, so now we are able to make the connection. Now we're going to create a table. Called the patient. Now make sure you execute it against the medical database. Don't. I always do make that mistake by accidentally create them in the master database. That's not fun. All right. So now we should be able to expand the database and see the medical, and we should have one table. All right. Now we're going to right-click on that and select Encrypt column, and this will bring up Always Encrypted Wizard. All right. So select the column you would like to encrypt. So we're going to encrypt the SSN and birth date. So these two column will not be available to DBA for DBA to see. All right. So you can say for each column, should it be deterministic or it should be randomized. We're going to make SSN deterministic. So I suppose we're going to do a equals query, and birthday is going to be randomized. All right. Now, deterministic should really only be used when every value is going to be different. Otherwise, if you do, for example, a column like US 50 states, it's not going to be hard to group by encrypted value and figure out, well, 90% of the people lives in New York, and this value looks like 90% of the data. So in this case, SSN is unique across every single record. They're perfect for deterministic. Birthday can simply be randomized. All right, next. All right, and we're going to select Azure Key Vault being the key storage. Okay. Remember, the important point to remember is that we don't want a key to be stored in the database itself. So I'm going to sign in as myself. So this account I used to sign in that created a key vault. All right, so it's going to pull up your subscription and it's going to pull up your key vault. Since we only have one, this is it. All right, select next. All right, so we're going to proceed to finish, and we're going to just commit to do it now. It's also possible to generate a PowerShell script and run it later. All right, so it is done. All right, so once it's done, click on close. All right, now we're going to fire Visual Studio to try to build a console app. All right, so now it's loaded up. By the way, if you expand securities, you'll find in the SSMS always encrypted keys. All right, so there is the column master key, auto-generated, column encryption key. All right, so the column master key decrypts column encryption key, and the key vault key protects the column master key. Now you want to make sure that people who needs to decrypt them have access to data dictionary that points to the key vault location. All right, so now in Visual Studio, we're going to create a new project. There will be a console app, sort of like a hello world. All right, the project name matters little. Okay, actually I need to go back because I selected .NET Core, and based on this instruction, I should install console app .NET Framework. Okay, the instruction has .NET Framework 4.7.2, so make sure you do not choose the one that's .NET Core. Okay, so this is the framework version. Click on Create. All right. Now the Lab 10 folder from all files that's downloaded for this lab exercise on GitHub AZ500. In the module 10 folder, you're going to find this program.cs. Just copy everything, Control A, Control V, paste it over. Don't worry about the wiggly line yet. Okay, go to Tools. After you paste it, go to NuGet Package Manager under Tools and open up Package Manager console. We need to install a few packages. The lab instruction will have the 2 install package we need to run, namely the SQL Azure Key Vault Provider and the Microsoft Identity Model.clients.active directory. So these 2 packages, I think it's pretty self-describing. The first package makes sure you have the Key Vault the necessary library to interact with Azure Key Vault for always encrypted, and the second one just helps your application sign in to Azure AD. All right, so there's a couple of things we need to fix up. So while it's installing the package, we need to get the connection string, the client ID, and the client secret. So all of those we copied earlier. So I've got to take care of that one. All right, so here's the notepad. This is my connection string. It's long, so. All right, next, client ID. Client ID is the GUID. First line here. Client secret. We obtained that when we created the application principal or the app ID. All right, so there you have it. All right, so we're going to give it a spin. So as part of building the connection string, okay, make sure the property colon encryption setting is set to enabled. So it tells the driver that to observe the location of the key vault and goes out and fetch the keys in order to retrieve and store data into encrypted columns. All right, so here we go. So it's going to ask you to enter your server password, and this is going to add some sample data for us. Now it's going to come back and say, well, if you enter a valid SSN, so let's give that a try. We're able to query using a where SSN equal. Now I'm going to switch back to SQL Server Management Studio, and I'm going to create a new query. All right, so you'll see that the data that's existed in the database is in binary format. Now, when I made the connection to this database using SSMS, I did not choose to enable the always encrypted option. Okay, so if you do a connection to a database engine, you may want to go to options, always encrypt. Okay, and then select that. Now, if you are authorized for the key vault, then your connection will allow you to see the actual data. Okay. Perhaps we don't have authority for that. Yes, we don't, because we're signing in using I just realized we're signing using SQL Server authentication. But if we were to use SQL integrated authentication, then if we were using Azure Active Directory login, then we could transparently get to that key vault. All right, so I must remind you the idea behind always encrypted is that the data that ever lands into SQL for port 1433 is already encrypted. When the SQL Server returns the data, it's just a series of bytes. Okay, and those series of bytes has to be decrypted by the client application. All right, so that's made evident the fact that we can query and find data using equality comparison, and a DBA can look at the data all it wants. Okay, the data would not be accessible. All right. Okay, so it would just, well, I guess we have access to it. There we go. Apparently we are signed in, and it must have stored my Azure credential here at some point. All right, so I'm going to disconnect from here. And use an option to disable always encrypt. All right. Of course, because that was this account that's encrypted it. So let's do a refresh. All right. So without the always encrypt, it's not going to supply my Azure AD credential, and that is going to come back encrypted. This is the lab 11 for the AZ500. In this lab, we're going to review all the security features built into Secure Your Azure SQL database. We're going to start by deploying a custom template. Now, this template is available from the GitHub AZ500 download. And one quick point of note is that if you are deploying this template using Azure PaaS, you may want to select region East US 2. There's some limitations to the Azure PaaS. Okay, so you do a custom template deployment, load up module 11 Azure deploy.json. and send it for creation. Fast forward this a bit. Alright, so the resource template is deployed. Let's go to the resource group. Now, understand that Azure SQL database consists of two resources. One is your server security settings, and these security settings applies to all the database that attaches to it. So here is the actual database where our data is stored, and this is our server object. Okay, so let's click on the server object. All right. So in this section, you'll find under security settings. In this lab, we'll take a look at auditing, advanced data security. So let's go to advanced data security. We're going to turn on the advanced data security. Now there's a cost associated with it. So we're going to create a new storage account. All right. So I'm going to pick a globally unique name to store the various reports, logs. All right. So it's going to take a moment to create a storage account and return you back to the advanced security, advanced threat protection page. All right. So you would want to schedule a periodic report, a regular scan against your database, and you can configure a regular report delivery to your email address. Now, in the advanced threat protection type, this is going to watch out for all these different types of attack. Now, each one of these will have an example of what type of activity. All right, so click on Save, and we'll let the Azure's Cloud Intelligence help us defend our database. All right, so next capability is called data classification. Now, with this service, we have to navigate to the database themselves. All right, so under the security settings per database, okay, we're going to select Advanced Data Security. We're going to select Data Discovery and Classification. Now this is going to scan the database looking for personally identifiable information. So in this case, it identified columns as well as tables that contain sensitive data. All right, so we're going to click on this. We have found 15 columns. That's recommended to be classified as security sensitive information. All right, so notice it labels the sensitivity, the type of information. All right, so this makes short work by accepting these selected recommendation. Now, by labeling these columns, Azure can apply the threat analysis against attempt to access these columns. All right, so once it's saved, you can close the screen. Go back to overview. Let's force a refresh. All right, so still applying. All right, so make sure after you select accept the recommendations, you click on the save button. That's the number one thing. Always forget to click the save button. Okay. All right, so back to the overview page, it will see certain columns being defined as confidential. So attempt access to these columns will now be analyzed by the advanced data security. And next up, auditing. So let's go back to let's talk about auditing for a second. There is auditing at the server level as well as the database level. So we are going to start by looking at the auditing add the server object. All right. So here we're going to turn on auditing, and we have 3 places where we can send our audit entry to. Now the 3 different destination represents long-term analytics. So if you want to store them in the storage and perhaps parse them using some sort of big data solution to analyze a long-term trend. Okay, so that's storage, and they are stored as long as you want, as long as you're paying for the storage. You're good for that. And retention 0 will retain them forever. Okay. Log analytics. This is for you to be able to build a data warehouse against these auditing entries. The data warehouse would then be able to answer your query very quickly. You can use log analytic queries against these data, and typically we use this to build dashboards. Event Hub sends every auditing entry as event. Typically you can then define a stream analytic job against Event Hub, and the goal here is real time. So the 3 destination, archive, and permanent storage. Okay. For batch processing or big data processing, and this is for dashboard building and fast exploratory queries. While the Event Hub is the real-time response to these auditing entries via stream analytics. Okay, and there are other ways you can make use of these events that's stored in the Event Hub, but typically stream analytics is a pretty polished product designed for Event Hub. All right, so go ahead and save those changes. All right. Now we're going to navigate to the database and turn on database level auditing. So select the database. And you'll find down here auditing as well. All right, so we can choose to use the same storage account. Now you can define, once again, retention days for these auditing entries. All right, so as your database is being accessed, these audit entry will be generated. All right, so there's that. Now the lab exercise doesn't go into things like transparent data encryption. This ensures data stored at rest is always encrypted. Okay, this is not the same as column level encryption. This encrypts your data file, this encrypts your backups at rest. Transparent. Dynamic data masking hides data as it leaves your database server. So if someone makes a query and the dynamic data masking rule applies to them, they will see masked data. It doesn't affect how the data is stored in the data file. So dynamic data masking does not apply to DBAs. DBA will always be able to see unmasked data. So here you can specify what table and perhaps you would like to mask email address. Okay, and you can choose a default masking or show the first letter and the top level domain. So this will add a masking rule. Any user in the database that's not excluded from dynamic data masking, when they query the table, they will just see that. Okay. Now remember, keep in mind that DBAs will not be subject to these dynamic data masking rules. All right. So these are the built-in security features for the Azure database. Now, naturally, there's a couple more things I want to highlight. Above and beyond the labs. Now, when you're at the server, remember there's a server level firewall. Okay. So when you look at the SQL Server under security settings, all right, you'll find firewall and virtual networks. Your Azure SQL Server is running on the Azure infrastructure platform. It will be accessible over the internet, so this firewall controls what client IP address is allowed to connect. Now you can also have VNet connecting to the database, okay, because you don't always have a public IP exit out of virtual network. So you use this to specify which virtual network has access to these servers. There's also a database level firewall rule. Now you're not going to find the database level firewall rule using the portal GUI, because the database level firewalls are stored in each database data dictionary, and the rules in the database firewall rule is considered first. So if there is a rule in that database that allows certain IP address, it will be allowed before the server firewall rule is checked. It is designed that way so your database can be portable. So if you have a database on this server that allows IP address 1234, when you move this database to a different server, those rules will follow that database because it's part of the data dictionary. Now you create those database firewall rules using T-SQL. So you need to make a connection to the database and run a store procedure to create those rules. All right, so that concludes the lab number 11. Don't forget to clean up the resource group. All right, so this is going to be lab number 12. We'll be going over the service endpoint feature in a virtual network and use storage account firewalls to control which VNet subnet have access to the storage account. Now, service endpoint provides a direct connection from your VNet subnet to your storage service. Now, there are different kinds of service endpoint for different Azure services. All of them allows you to go directly to these cloud services without going through the public internet. All right, so with lab 12, we're going to start by creating the virtual network. All right. Create a virtual network. We'll be defining two subnets. One will be made one will be a public subnet, the other one will be a private subnet. So let's actually go back for a minute. So we need to make sure this is renamed. All right, so let's rename this to the public. All right. Now, public. Good enough. All right. So let's create this. All right. Now we're going to go to the VNet subnet and define another one. This will be the private subnet. All right, so for this private subnet, it'll be 10.01/24. Now we do want the service endpoint so it can have direct single-digit latency access to the storage account. Don't have any service endpoint policies, select OK. All right, So task number 3, we're going to set up network security group to control access to the subnet. So we're going to create a new resource. Network security group. And this network security group will apply to the private subnet. Now in this NSG, we're going to add an outbound rule. That allows our virtual network access to the storage service. So the destination will be a service tag, and the service tag will be our Azure storage. Right. So this will be an explicit allow rule. All right, I'm going to add another outbound rule that denies the access to the internet. So the virtual network that this will be associated with will be blocked of internet access, and this will be a deny, and this will be prioritized right after the 100. Now we're going to add an inbound rule that allows RDP from anywhere. Follow the instructions. All right, so now we have the rule laid out. We are going to associate that with our subnet. Now, once again, these NSGs and the VNet all have to be in the same region. So if your drop-down box doesn't show your virtual network, make sure you go back and select the right region. All right. So once that's done, we're going to create another. We're going to create a storage account. All right, locally redundant storage. All right, and make sure this is created in the same region as your VNet. All right, so we're going to configure some protection for the storage account. So now the storage account is created. Let's navigate to, before we configure the virtual network and firewall, we are going to create a file share. So here's the file service and here's the file share, and we want to add a new file share. Now, along with the file share, you'll want to write down the PowerShell script because we'll need this to map a drive. All right, now we have that information. Close that. Back to storage account, you're going to find a section called Firewalls and Virtual Networks. Okay, we're going to say only selected network should have access to the storage account. So I'm going to select Add Existing Virtual Network. And the subnet. So we want to make sure private subnet has access to it, not the public. All right, so we're going to deploy 2 virtual machines. One machine to each of the subnet. All right. And make sure the disk is just standard HDD is fine. Now, in the network, be very careful. We're going to have to select my virtual network and make sure it is in the private subnet. All right. We're going to give it a public IP, and no security group applied directly to the NIC. We're going to test the subnet NSG. All right, I'm going to keep everything at default here. Create that. All right, once it's on its way, we're going to create a second virtual machine, but on the public subnet. All right, so this is just a repeat. Okay, so make sure we deploy this to the public subnet. Okay, so keep everything at default. All right, go ahead and create that. All right, so it looks like our private VM is ready. I'm going to go to virtual machines and make a connection to the private VM. All right, so it's now logging into this private VM. We're going to try to run that PowerShell to see if we are able to make a file share connection. All right, so we're going to fire up the PowerShell ISE. All right, so we're going to click on the script to expand the script section, paste our copied script. And let's go and run script. All right. So now it connected the Z drive. So we know this is a success. All right. So next, we're going to test if accessing to a web location is allowed. All right. So I'm going to do a test net connection. Our NSG should block this outbound connection. So what this tells us is for us to access that storage account, we must be not going out to the internet. So we must be using some sort of internal access, which in this lab, we're using the service endpoint, essentially the dedicated private connection to our storage account. So this test connection eventually will bail out. All right. So you see that it's attempting TCP connect, waiting for response, and it will just be blocked. Our next test is for the public VM. Because our storage account did not allow the public subnet to connect to any of the services. So if we connect to the VM that's deployed to the public subnet, mapping the drive should fail. All right, so making a connection to the public VM. All right, so in this public VM, we're going to do the same thing as we did before. And we expect this connection to fail because our storage account doesn't have this subnet as an allow subnet to consume its service. And we're going to say run script. Right, so it's trying to verify connectivity. All right, so it looks like it's able to successfully connect, so that means we've done goofed somewhere along the line. So let me minimize this and find out how we goofed. So let's go back to storage account. On the storage account, let's make sure that I actually did remember click on the save button. Yep. So I did do the select network, I did add existing virtual network, and if you rewind this video, you'll probably see me forgetting to click on the save. Why? I don't know. So add that, make sure you click on save. All right, now I'm going to disconnect the Z drive and try again. All right, so trying the second time, I should get access is denied. So that's a good sign. Does that mean we rigged the first exercise? I'm not so sure. So let's go back to the VM. Let's disconnect this one as well and rerun the script and see if we actually rigged this exercise. Hopefully not. So I'm going to disconnect that. And I'm going to try to rerun the script. Yep. I did disconnect it. Come on now. Alright, you know what? I'm going to change that to W drive. How's that? Alright, so notice my private VM can still connect. My public VM is not. Alright, one last test. The public VM should have no problem getting to the internet because there is no outbound rules that blocks it. Alright, so test ping returns almost immediately. Alright, so connectivity is just fine. Alright, so this is the wrap for lab number 12. Don't forget to clean up after this.